Welcome back to the
Inside Java Podcast.
a podcast about everything Java, brought to you direct from the folks at Oracle who work on Java. My name is Chad Arimura, and I'll be your host for today's episode. And today's episode is going to be awesome because we're celebrating the release of Java 19. The talk of the town for Java 19 is Project Loom right now. With a pretty major release included in Java 19, Project Loom delivers preview features for virtual threads and an incubator API for structured concurrency. To talk about Project Loom, I'm bringing on the man, the myth, the legend himself, Ron Pressler. But not to be overshadowed, Project Amber is bringing a preview feature in record patterns. Record patterns are an important piece of the Project Amber story in that they represent a continuation of the story of data-oriented programming. Really, who better to bring on than the chief language architect himself, Brian Goetz. So stick around, you're not going to want to miss a single word. Let's go ahead and get started. With us today, again, is Ron Pressler. Ron, welcome back to the show.
Hi, good to be here.
I think most listeners by this point are familiar with Project Loom and virtual threads, but I thought it would be interesting to talk a little bit about the history and the intent. So when did you set out to look at this space, and what was the problem you were trying to solve? And tell us a little bit about your journey towards this closed delivered status.
Right, so this was sort of a roundabout journey that started a while before I joined Oracle. In fact, I was working at a small company that made an in-memory spatial database for soft real-time location-based applications, etc. It didn't sell too well. That's why I'm here today. But when we were trying to sell it to people, in order to use it, it was very concurrent and very low latency. And in order to make the most of it, the API had to be asynchronous. And we tried to sell it to gaming companies and defense companies. And what many of them said was just that they're unwilling to do anything asynchronous. They just don't want to deal with that kind of code. And so this was about 2012. I've already known about Erlang and Go. And I thought that this might be the right solution to write synchronous code and get the same benefits I needed with asynchronous code. And I started an open source project called Quasar that was meant to add sort of user mode threads in Java as a library using bytecode instrumentation. It started out as a side project, but I think it was Alexei Shiplev invited me, he worked at Oracle at the time, invited me to present it at JVMLS. By then it was 2015, I think. And I did, and then I met the JPG team. And after a while, they asked me if I wanted to join Oracle and work on it inside the JDK. And of course, doing it in the JDK itself gives you much more power. And this took longer than I expected. I thought it would be 2 years. It ended up taking almost 5. Much of it is because we've done things very thoroughly. I think the whole thing was implemented at least twice, if not 3 times. From scratch twice. Also, integration with the tooling, which I said was very, very important, especially with debuggers and profilers. That took a lot of the time, and that was very important. We wanted to get it in there right from the start. I know other languages and platforms first added user mode threads before they had tooling and debugging support, but we wanted to have everything from the start.
You know, it's been a long journey, as you say, 5 years. In other ways, it's kind of just the beginning of another journey, which is moving through preview into standard and then seeing where this is adopted. Was there a moment that you took a pause, maybe with Alan and the rest of the team and celebrated? Did you maybe crack open a bottle of champagne or something like that in the office?
Not yet, because we're not in the same office, and we haven't met each other for several years now because of COVID. But we will, yeah. After 19 comes out, I don't know when this is going to air, but in a few days from when this is being recorded.
Yeah.
And we can celebrate after when we finally see each other.
Awesome. So in the last Inside Java newscast, which should also come out any day now, we briefly talked about Jetty and Tomcat, and you had mentioned that Helidon, I think it's Helidon, Nima, Quarkus. There's a bunch of projects that are already looking at being early adopters of virtual threads. What are your thoughts on the classes of projects that, maybe obviously web servers is one of them. Do you see classes of projects that will be adopting this and what people should be looking out for?
First of all, I was pleasantly surprised to see that happening. Normally, when Java comes out with a new feature, first it's released, and then it takes a while until anyone starts looking to use it in earnest. And virtual threads are not yet out in preview, and projects are already experimenting with it. So first of all, this is one thing they should do, start early. And they're doing it, many are doing it, and that's good. Another thing that's very important, and could be the difference between success and failure, is for people to read the gem. There has been some misunderstandings about how libraries in particular, or sophisticated frameworks, should adapt to virtual threads, and it's best to just read the gem. For example, some people thought that they should never use synchronize blocks. That's not true. It's perfectly fine to use synchronize blocks for in-memory operations. In fact, it might even be better. Some of the things that are the biggest issues, for example, caching very expensive objects inside thread locals, are actually much bigger problems. So we try to cover most of that in the Jet 425. So anyone who wants to do anything with virtual threads, I would suggest they read that first. Second, some people are very excited, and it's very good, but they're trying to be a bit overly ambitious. I saw someone on social media the other day who said, okay, so I took some web server, Undertow, I think, a JDBC driver, a JSON library, and something else, and I tried to tweak them a bit to work best with virtual threads, and I'm not yet at full performance. Like, yeah, start gradually. It's best to look at one layer at a time. And currently, I think the best example for people to look at is Helidon Nima. So Helidon tried to adopt virtual threads, and they did something very trivial, but they didn't get good performance because the engine they used under the covers cached very big, expensive objects in thread locals. And once you have a million threads, and those threads, caching objects in thread locals makes sense when a thread is long-lived, there are a few of them, and they're shared. So you cache something in a thread local if another task is going to use this thread. None of these is true for virtual threads. Virtual threads are very short-lived. They're never pooled and never shared. And there are lots of them. Mm-hmm. So they didn't get good performance, and they asked us for advice. And we said, why don't you start just writing everything using regular synchronous code? And they tried writing a web server using basically Java 1.0, 1.1 APIs. Just created threads as needed. I think every HTTP request, they created 2 threads for it, one for reading, one for writing, to the point where they got to 2 million new threads per second. But within a few weeks or a couple of months, they got amazing performance to rival the best Java servers out there.
Wow.
But the general advice is to get a feel for virtual threads first, not to go by things you might have heard. Read the JEP, that's the authoritative source for information, and play with it. Start simple. One of the issues is that virtual threads behave just like platform threads. There is no difference in semantics. The interesting bit is getting every last percentage point of scalability. And getting there is not necessarily a trivial thing, because many existing code bases do have these hidden assumptions about there being very few threads, about them being shared, such as caching things inside thread locals. So take your time. Preview is a very good time to prepare for a feature. So during the preview, I hope libraries prepare for the ultimate finalization of virtual threads in the JDK. So when that happens, they'll be ready.
This might be an early question. I'm getting attacked by a moth here. This might be an early question, but has anything surprised you yet about the pickup or the way that it's been used, or from feedback directly from folks who are picking up the, or I guess early access builds of the Preview feature?
Yeah, I was mostly pleasantly surprised, first of all, by the excitement. And even though that excitement could lead to people trying to be overly ambitious, it's not that you can't get there, it's just that you have to get there in steps. I loved some, toy experiments that people did online, and it gave them joy, and so it gave me joy. For example, there was this guy, I think his name is Elliot Barlis, who wrote a cute demo implementing the game of life, where every cell uses a virtual thread and created channels to communicate between them.
Super cool.
That was very cute and worked very well. And it was fun to see, and we got many people interested. And I think he did another experiment he ran a server for a while with several million connections or something like that. And that showed people some of the possibilities that virtual threads bring. So yeah, I was surprised to see those things, happy to see those things. And we will probably see more of them.
By the way, JEP 425 is probably the model JEP for all future JEPs. I've looked at it and read it a few times now, and the work that you put into it.
It took us so long to write it. One of the lessons we learned for the future is that it's best to, you don't want to start the JEP too early, because the project changes. So you say, oh, if I write it too early, then I'm going to have to go back and change it. Of course, it requires review, and normally the big JEPs write together with Alex Buckley, who's an expert in how to write good JEPs, both in terms of precision and pedagogy. But one of the lessons was that we started too late. It took a very long time. It was very intensive. And then we had to do it again with 428. So lesson learned. Next time, we're going to start working on the JEPs earlier.
Well, let's talk about 428 for a minute. So I think that there weren't any surprises to see virtual threads move into preview, but then structured concurrency, actually, for me personally, sort of came out of nowhere. I know that you've been talking about it for a while and we've been tracking it, but to see it as an incubator API was, for 19 specifically, was pretty cool. Do you want to talk a little bit about structured concurrency and how that relates to virtual threads, and who should care and who should be looking at it?
Yes, but first, actually, this gives me an opportunity to speak a bit about JEPs and projects. So some people identify Project Loom with virtual threads, and Project Loom is a group of people that come together to produce JEPs around a certain subject area, which is Java concurrency. So Project Loom is not a feature, and we produce features that hopefully end up as being JEPs that are then accepted into the JDK. So the big one was, of course, virtual threads, which was JEP 425, and it is previewing in JDK 19. Maybe later we should talk about preview versus incubation. And the second was JEP 428, which was structured concurrency. And the third, which didn't make it into 19, but will hopefully make it in 20, is JEP 429. And that is scoped values. Maybe another time we'll talk about those. So structured concurrency, it didn't come out of nowhere. We were working on it. It's just that it's compared to virtual threads, yes, it's less of a bang. But it was very important to us when we give people the possibility to create and use hundreds of thousands of threads or a million threads, to also give them better mechanisms to manage them, like to herd them. And we didn't want to just say, okay, so now you can create a million threads without giving people also a better way of working with groups of threads. So structured concurrency is a way to manage a group of threads that work together on something. For example, say you're writing a server, and in the process of handling a request, you want to fan out. So you want to emit outgoing HTTP calls or database calls to multiple microservices and databases, etc. You want to emit them in parallel, wait for them in parallel, and then combine the results. And currently, the way to do that, or before JEP 428, is just with futures and execute services. But in the JEP, we describe certain problems that arise. For example, if one of the tasks fail and you want to cancel all the others, it turns out to be quite more complex. If the originating thread is interrupted because some timeout expires, it's very hard to actually cancel all the other subtasks. And if you want to observe such a running up application in a debugger, one of the observability tooling like stack dumps, you don't see the parent-child relationship between the parent task and all of its children as you do in single-threaded code. So in single-threaded code, you see, oh, this method is called by some other method, so it's working on its behalf. But once you split, you found out all the relationships between the originator or the parent and the children gets lost. So it was important for us, both in observability and in terms of handling errors, cancellation, timeouts, to make it the same hierarchical organization that we have in synchronous in single-threaded code will also pass us on to multi-threaded code. So with structured concurrency, the API we're introducing is called structured task scope, and you create a scope, you create subtasks inside that scope. The API is quite similar to executor service, but then you can cancel them all at once, or you can say that your policy is if one of them fails, then the other should be canceled. Or you could say the policy is if one of them succeeds, then you have your answer and you don't need to, you automatically cancel everyone else. So it gives you mechanisms to manage a set of threads as a group, as a unit, and it also lets you observe them as a unit. So it introduces a new kind of thread dump that shows you this hierarchical relationship between tasks. Who's the parent, who's the child, who's waiting for who, etc. So it's important for everyone who wants to write code like this. So it's many people. But it is only incubating. It's not yet preview.
I know this is mostly about 19, but since we're on the subject, do you want to talk briefly about extent locals?
So yes, the first thing I want to say about them is that as of this week, we decided to change their name. The current name that we have in mind is scoped values. I hope it's the last time we change the name. And one way to look at it is sort of a replacement for many uses of thread locals, only they have better performance, they consume less memory, and they help write more correct code. Another way to look at it is that they address the common use of thread locals of passing information from some caller to a transitive callee without the methods in between knowing anything about it. So instead of passing an argument to one method, then pass it to the next, and then to the next, you can have sort of an implicit context that you want to associate. But instead of just associating it with a thread in sort of an unstructured way, that you first set it and then it has this value until someone else. Thread locals behave sort of like mutable global variables. Scoped values that until this week were called extent locals are immutable. They create a binding for a very well-defined scope of the program. And they work very nicely with structured concurrency. So all the subtasks that you create in a structured task scope would automatically inherit the value without any performance costs. You can associate something like, a session key, but then when you fan out to multiple threads, they all inherit that value. But scope values are not going to be in JDK 19. Well, they are not in JDK 19. We hope to finish them in time for 20.
You've been busy.
Yes.
Well, this has been a great overview of Project Loom and two of the three major components of it coming in JDK 19. You've been on the show a number of times. The question we always ask is, tell us a little bit about a day in the life of Ron Pressler. In particular, where do you find the time to spend in Reddit and Hacker News? We commend you for that effort. It's always great to see you in there. But where do you find the time? Do you sleep?
Yes. Actually, since Jet 425 was integrated, a bit after that, I don't code as much as I used to, so I have a bit more time. Before that, there might have been a while there that I didn't quite sleep. Reddit. I don't know what to say about it. Yeah, it's sort of a maybe compulsion, obsession. Sometimes they do good work. But what does a day look like? Nothing. One thing I can say that ever since COVID started, we have a morning informal coffee meeting that started out for the people in Dublin, but then extended to most of Europe. So the people in JPG who are in Europe in the morning getting together over coffee. Sometimes it's just a few, sometimes it could be 7 people. Then every day is a bit different, sometimes I need to prepare talks. This is what I do these days. So conference season is coming up, so preparing talks. Other times it could be, keeping an eye on bugs, thinking about future features, thinking about future ideas. Yeah, nothing too structured.
Speaking of conference season, there's one coming up called Java 1. What's your talk on?
Probably virtual threads. I don't remember what was my submission, but that would make the most sense.
Wow. Come to Java 1. Ron will be hanging out in the Meet the Experts section. He'll be thrilled to hang out with everybody, I'm sure. And we look forward to seeing you. I look forward to seeing you in just a day over a month, I'd say. So get your shoes ready because we're going to be. Hey, do you run, by the way? Are you a runner?
No, sorry.
I'm leading the Java 1 run, and so
how
that's
long
one of
is
the
it?
activities that.
What distance?
I think it's about 3.5. It's not too bad.
3.5 miles.
Just. Yeah. Oh yeah. What is that? I don't know. 5 kilometers.
Yeah, it might be a bit much for me.
It's we'll take a slow pace up the north side of the strip in the morning, so it's not too bad. But in any case, Ron, I really appreciate it. As always, thank you, and thanks for your hard work, both on the engineering and architecture side, but also helping our team out in all the various threads. Continuing to get the good word out there of all the great things happening in Java. So, thanks, and I'll see you in Vegas in a month.
Thank you, and see you then.
And my next guest is Brian Goetz. Brian, welcome back to the show.
Hey, Chad.
So Loom has taken some center stage in this release, and I talked to Ron about that earlier in this podcast, but I definitely don't want to miss out on the importance of record patterns and what that means for the journey of the Java platform towards data-oriented programming. Can you tell the audience a little bit about what your vision is for data-oriented programming?
Yeah, so, the phrase journey really does sum it up because, even though Project Amber has a mission of aiming at what you might call smaller productivity-oriented features, there is a really long and integrated feature arc among a bunch of the features that are in Project Amber, and in particular, records, seal types, and pattern matching. And each of those has a number of sort of sub pieces that are being broken up into multiple steps. And so the story is going to play out for quite a while. But, even though these features really stand on their own perfectly well, they're designed to work together. And in particular, they're designed to work together to facilitate making it easier to model data as data in Java. So records were the first piece of that, where records are, you could think of them as nominal tuples. They're shallowly immutable holders for a specific specific grouping of data, and they're constrained so that the data that they represent and the API that they export to represent that are aligned. And so that makes it really easy to declare aggregates of, I've got a name and a score, and I'm going to put them together into a well-behaved object without having to spend 20, 30, 40 lines of code doing so. And that, has an obvious benefit of concision, but it also has the benefit of raising the importance of data in the programming model. And a lot of the things that people complain about in Java and Java is so verbose kind of complaints that we've been hearing for a long time largely have to do with how difficult it is to model data using objects. And I sort of think that we should just model data as data. And, that's not to say that objects are bad or that object-oriented programming was a mistake. Object-oriented programming has a lot of benefits when you're building, for example, things like, libraries for parsing JSON or what have you, right? And we use object-oriented principles very effectively when we build libraries, but sometimes data just wants to be data. And that should be a choice that Java developers have.
Yeah, one thing that stuck with me from probably our last conversation here on this podcast was you had said we're living closer to the boundary now of where the data exists. It might have been in the past where you have this large application and then at some point data comes in, but then you're working inside the class model and the object model and you do a bunch of operations and then eventually the data ends up somewhere else. But now we've got serverless functions, we've got microservices, we've got machine learning, we've got, of course, in the word itself, data science, and we're close to the boundary of where data lives. And so this model and this pattern really is meant for that type of that workload.
Exactly, and we're working in a time where not only are program units smaller and more homogeneous and less in need of having internal boundaries to manage complexity, but also the things that they're talking to are not necessarily other Java programs. So, back in the Java EE days, we had monoliths, and monoliths, they talk to other monoliths, but they did so by serializing Java objects and passing them around. And so the data always stayed in the Java object model. And now, you may have a polyglot application where some of your services are written in Java and some are written in Go and some are written in Python, and they're going to communicate through some I don't want to say untyped, but basically untyped, mechanism like JSON or something like that. And, you obviously don't want to program with JSON in your Java program. That would be painful. And so when data comes in from another service and it comes in this, untyped, unvalidated schema, no schema, sort of way, you want to validate it at the boundary and then turn it into Java data types that are sensible to manipulate within your program. And you don't want that to be 1,000 lines of code. You want that to be a handful of lines of code.
Yeah, really fascinating. And we talk about each of these releases. We have these slides and we do market updates. And there's always some progress with Project Panama now and Project Loom and Project Amber. And we even talk about Valhalla, Leiden. But the interesting thing is that they're not these isolated projects that are just tackling one particular thing. They actually happen to really fit into this vision of where the world is going. And that world tends to be, very data oriented, very data driven, machine learning oriented. People always ask, when is Java going to advance with machine learning? And we always say, well, look at all the advancement it is making now, and look where Panama is, and look where Loom's coming, and let's not forget about Project Amber. So all these things really start to fit together in a cohesive vision. It's almost like, Brian, someone's thinking about this all the time.
Almost like that, huh?
It is almost like that.
Almost like somebody's driving this bus.
So let's see. We've talked about records and data-oriented programming. Let's talk about Actual 19. So JET 405. Record patterns. How does this extend pattern matching for records, and what does that empower developers to do?
Yeah, so pattern matching, is we introduced it as a very simple feature, in the first iteration, where it's basically was streamlining the instance of cast, idiom. And that was, deliberately small, unambitious way to introduce the concept of pattern matching. But, the long-term goal is to make taking data apart and just as easy and look just like putting data together, right? So Java is really good for building libraries that can compositionally put objects together and then put them in bigger objects and put them in lists and wrap them with with things. And we're used to doing that all the time. But if you try to reverse that, if you want to take apart a list of a list of records, first you have to take apart the list with whatever API the list list class gives you. Then you have to take apart your individual data items with whatever API that gives you, and they generally don't work as well together. And so pattern matching is the bigger goal is to make taking things apart just as easy as putting them together, and have it look syntactically similar to the way you put things together. Because if you take things apart in a different way than you put them together, it's really easy for bugs to creep in. Whereas if the take it apart code looks a lot like the put it together code, it provides a sort of built-in normalization to help you get it right. And so record patterns are the next piece of that, but not the last piece of that story. And so record patterns make taking records apart as easy as putting records together with their constructor. And looking ahead to the the future, obviously we don't want to just do that for records. We want to do that for all Java classes, and we want to make it easy for APIs to export conditional destructuring in a natural and not ad hoc way. And so there's obviously a lot more work to do in this story, but record patterns, I think, are the first significant piece of it that sort of like signal the direction we're moving in.
Mm-hmm. Yeah, I've heard the words disaggregation. I've heard the words deconstruction. Do both of those accurately capture part of what's happening with record patterns?
Exactly. I think probably the most commonly used term across languages is destructuring, and that mostly comes from languages that have structural type systems. Like in Python, where you have built-in data types for sequence and dictionary. So those are structural types. A sequence of X or a dictionary mapping, X to Y, and many languages, especially functional languages that have structural types, have built in a mechanism to take apart these structures and ask questions about these structures. And so destructuring is probably the most common term, but you'll find different terms used in every language. And so we toyed with the idea of destructor, but that already means something else in C++. And so deconstruction is the term that we're probably going to settle on, and the opposite of a constructor is a deconstructor.
Let's talk about the future a little bit. Do you think, I know preview still means there's a future with record patterns, but do you think there's a future in, say, class patterns or something of that nature?
Yeah, totally. I mean, it was easy to do records first because records have this very tight constraint that their API can be derived from their representation. And so it was really obvious how the compiler can generate a deconstruction pattern for records, because it knows what the data description of a record is, and it knows where to find the data and all of that. And so that had obvious semantics, and it has easy implementation. When it comes time to saying, well, I want to be able to take apart any class, not just a record, well, now the user's going to have to write some code, just like they had to write a constructor that says, okay, this constructor takes X and Y and packages it up together, in an XY point. They're also going to have to write some code to take it apart, saying, okay, here's some deconstruction behavior on a point, and it yields as its bindings X and Y. And that won't be difficult code to write, but it is new language surface, new syntax, and so that will take a little bit longer to do.
And this is the moment where I'm going to plug Java 1. Definitely come check out a lot of the content. I know Gavin Bierman's got a talk on exactly this, and so we hope to see everyone there. From the day this releases, we're about 26 days away. Brian, I would say congratulations on the launch of 19. We're still, we're recording the day before, but 10 releases now. They've each been so smooth that, we almost can congratulate people the week before they even launch.
Yeah, it's been an amazing transition to the to the rapid cadence, and one of the amazing things about it is you almost don't think about release dynamics at all. You can just work on the things that you're working on. When something's ready, it gets proposed to target. And by the time 19 ships, we're already working on 20.
So listeners of the podcast have surely heard you talk about a day in the life of, I guess is how we position it. But I'm going to ask you a slightly different question. What does Brian Goetz do to make space in your life to think about these hard problems and how we go about solving that? And part B or part two is, does it have anything to do with what you're soldering there on the floor of your office?
Well, I certainly hope they're related. I try to spend time away from my desk. Because when you're sitting at your desk, you're looking at the computer, and the email's going and the Slack's going and everything's distracting you. And most of the work that I do to move things forward, I actually do on, pen and paper. And I try to, get away from my desk, take that to the porch or the couch, or, and the project that you see behind me with the soldering irons and such are all all in preparation for our home improvement project that we're working on now, where we're building a sauna in the backyard. So I'm doing some of the construction. I'm doing all the wiring and interior finishing. So that's what you see spread out on the floor behind me that the listeners can't see.
Well, Brian, as always, I appreciate it and everything that you do. Thanks very much for joining us again on the Inside Java podcast.
Yeah, my pleasure. Take care.